Welcome again. In our discussion of the Turing test, now we will talk about different variants of the Turing test because, as we said before, the Turing test has these problems, that it is easy to cheat and that you are probably not even talking with the machine, you are talking with the program of the machine. And all these arguments we saw, the subcognitive tests of French. Therefore, we want to see what other possibilities are there. What other tests could we imagine that would tell us whether a machine can actually think, and a test that can be used as a thinking test in order to define machine intelligence or to detect it. So this is what we will do next, variants of the Turing test. And one that is interesting because it's so different from the Turing test in a way is the Kugel test. The Kugel test attempts to be a version of the Turing test which rules out dumb programs like Alice and finite state machines, that rules out programs that are pattern based, because essentially the Kugel test doesn't use language, it uses pictures. And now if you look at this here, you see that everything begins with a judge who thinks of a concept. In this case, let's say the judge thinks of the concept of an animal. And the judge now throws picture cards into one of two bins, depending on whether they fit the chosen concept. So the bins are a yes bin and a no bin. And since the judge has thought of an animal, he will put all the animals' cards into the yes bin and all the cards that show something else into the no bin. So you see the cat and the mouse go into the yes bin in this picture, while the sun and the cube go into the no bin. And the candidate now, who is the computer program or human being, of which we want to estimate the intelligence, has to guess which bin the next card is going to be thrown into. So now comes the picture of the bee. Will this go into the yes or into the no bin? And we as humans can easily do this right now, right? We can say, of course, this is an animal, it will go into the yes bin, even without knowing what the judge has thought of. What the judge thought of has to be kept secret, so we don't know what the judge thought of. But if you see, cat and mouse and bee seems to fit better than sun and cube and bee. So this is something we can relatively easily do. And this proves that we are intelligent. Or the question is exactly how do you want to judge this, or perhaps you do this with a human and you do it with a machine. And if the machine is indistinguishable from the human, then even if they don't always get the right answer, then you say that the machine is as intelligent as the human. So now, what are the advantages of this? Can you think for a moment? Why is this better than the conventional Turing test? Perhaps stop at this point the video, make a list. What are the advantages of the Kugel test compared to the Turing test? And also, what are the problems of it? Okay, so this test is run infinitely long, like the Turing test. So is this now a good test for machine intelligence? The advantages of the Kugel test, the first one, it does not use language. So people who speak another language would not fail. This is one of the main problems of the Turing test. If you say chatting on a chat interface proves that you are human or you are not human, then all the people who don't speak your language will turn out to not be humans, which is somehow wrong, right? So in this case here, at least, people who speak another language would not fail. It uses abstract classes to judge intelligence. Abstraction and categorization is a core intelligent task that is hard to fake, as opposed to generating correct language, syntactically correct language. It's easy to make a program to generate sentences that are grammatically, syntactically correct, although perhaps they don't mean much. But it is difficult to even fake categorization. You have images of bees and cats and mice, and to understand that all these are animals is a kind of intelligent behavior, and it is not clear that this is easy to do if you are not actually intelligent. Each picture now also can fall into multiple categories, right? A bee can denote insect or flying thing, or yellow black. There's a mistake here. Yellow black, small object, dangerous animal, and so on. So there really is some intelligence necessary in order to get the right category, depending on the other pictures that you saw previously. You have also to consider that pictures can be photographs, they can be drawings, they can be children's book style drawings, they can be Van Gogh style images. To get the right identification for each of the different ways of depicting something is itself difficult and is an intelligent task concerning image content recognition, right? So in order for the program to understand that we are talking about a bee, it has to identify my drawn picture of a bee, which was pretty bad, with the picture of a bee as Van Gogh would draw it, and perhaps the picture of a bee as it would be in a realistic photograph, and has to identify all these things as bees. So this already is an act of categorization, of image recognition, which adds an additional layer of intelligence, of difficulty to the task. So would the Google test be easy to pass for a human is another interesting question. I mean, when we say we want to test whether a machine is intelligent, first we have to make sure that our test is such that a human can pass the test. And would a machine at all be able to pass it? And one problem, of course, are private concepts. Things I saw last week. So nothing prevents the judge from taking a private concept like that and using that in order to categorize the pictures into bins. So if I say things I saw last week and I put them into yes and no bins, then obviously this will be very difficult. This will be impossible for a machine to pass. It will also be impossible for a human to pass, because nobody except me, this is why it's a private concept, nobody except me knows what I saw last week. I might have seen a bee, I might have seen a truck, I might have seen a flowering cactus. Nobody can know what I have seen last week, and so I might create actually a bin, the yes bin, that contains a flowering cactus, a truck, and a bee, and then good luck trying to guess what happens with the next card, right? So this is a way how I can make an unpassable Google test, and this will be equally unpassable for a machine as it will be for a human. So I can ask, is this still an intelligent test now in any way? Is this, where is the intelligence? Now this has become test of magic, trying to guess what the other person is thinking of. Humans would also fail, not only with private concept, but perhaps also depending on knowledge, cultural background, and so on. I can easily say use a concept that requires particular knowledge. For example, things that are inside a desktop computer, and now I can start showing you different kinds of electronic printed circuit boards. Some of them will be graphics cards, some of them will be hard disk controllers, some of them might be controlling boards for a laser pointer. Now, without a very deep and detailed knowledge of electronics, you will not be able to say what the problem is or what the next board goes into, because you really don't know what this kind of board is, right? It's not easy to just see a picture of a graphics card and identify it as a graphics card, as opposed to any other kind of board. Or it can even make a category, boards that are by default in a computer when I buy it, and boards that are typically extension boards, which I can fit into the computer, but they are not typically built in advance. Like, for example, a sampling board that converge analog inputs into digital outputs. So this would be concepts that are impossible to guess without detailed knowledge. I could ask, which of the following subatomic particles, assuming that I have a way of even depicting them in a picture, which of these subatomic particles have a right spin or a left spin or a positive and negative, or however physicists do these things. So these are all knowledge concepts that depend on particular knowledge that is so deep and so arcane that nobody is likely to succeed. Normal people and only specialists in a particular area of knowledge can succeed. Cultural background, right? I might ask a Greek person, which of the following artifacts are part of the Greek culture, right? So every Greek person will know. So if I put, I'm not asking like this, of course, in a Google test, but I'm showing you pictures. I'm showing you pictures of a little coffee brewing can that has a long handle, and I'm showing you a Greek flag, and I'm showing you the dress, the picture of the dress that these soldiers in front of the syntagma of the Greek parliament are wearing, which every Greek knows. And perhaps I'm showing you some other Greek artifact like the tomb of Kazantzakis in Heraklion on Crete. So these are things that most Greeks will know. So if I show you these things mixed with other artifacts from other cultures and ask you which are Greek culture, then you will be able as a Greek to identify them. But if I ask you the same question and you happen to be a Chinese or an American or a German, then good luck answering that, right? Because you're not going to know these artifacts, right? So cultural background can make you pass or fail a Google test. So this is a very difficult test to pass for anyone. It's probably therefore not usable as an intelligent test for machines because it is just too difficult to pass. So perhaps the machines then should be allowed to fail where humans also fail. This would be a possibility to say, if most humans fail, then the machine should also fail. But then again, it depends on my selection of human subjects. If I select all Greeks, then it becomes essentially a test not of intelligence, it becomes a test of Greekness, right? Because now all Greeks can easily pass the test, but foreigners cannot. But since all my human subjects are Greeks, now for the machine to have an indistinguishable performance to my human subjects, it would mean that the machine has to understand Greek culture. It wouldn't do to just have a machine that is perfectly intelligent but does not understand particular aspects of Greek culture. So another kind of test, another way of trying to repair the problems of the Turing test is Schweizer's. True Turing tests, real Turing tests. So there are various attempts to make Turing tests more and more true to what they actually are supposed to be measuring. Schweizer had the idea that generally it is not what we are doing, is not trying to attempt to answer the question whether a random thing is intelligent. This is not what we do in real life. I never wonder whether this here is intelligent. This is not a question that concerns me. And I'm never asking this question, and I never even attempt to have this pass a Turing test. I never say, oh, hello, what are you doing? And then it says, oh, it doesn't answer, so it's not intelligent. I also don't do this with my human friends. The moment somebody comes through the door, I'm not going to ask them first thing, let's pass a Turing test quickly so that I know that you're human and intelligent, and then we can continue to speak. The moment a student passes through my door, I am assuming that they are intelligent. Otherwise, they wouldn't be students. They wouldn't come here to ask me something. So it is not like we normally perform Turing tests on unsuspecting subjects out of the blue. We don't do this. What do we do really is we have an assumption about particular kinds of things that are likely to be intelligent and about other kinds of things that are not intelligent. Nobody would ask this to pass a Turing test because just by looking at it, I can say, this thing, structurally, for example, it is not complex enough to be intelligent. It doesn't seem to have the functional components that would be required for intelligence. It doesn't have enough states. It can be open, closed, that's all. It can be open to some particular degree. This is not enough states in order to process information in a way that would make it intelligent. It doesn't have any input or output elements. So immediately by looking at it, I can say this thing cannot possibly be intelligent. On the other hand, seeing a dog in principle has lots of states in its brain. It has a neural network. It has a neural system in it. It has a brain. The brain is a mammal brain. It's similar in ways to my brain. It has eyes. It has ears. It has a mouth. So it is perfectly possible that a dog is intelligent to some extent. And there the question makes some sense. I could imagine making an intelligence test with a dog. Again, I wouldn't do a Turing test because I know that the dog doesn't speak. It's the wrong kind of animal to expose to a Turing test. It will never be able to pass a Turing test, right? But I can imagine an appropriate intelligence test for a dog, and indeed intelligence tests are done on dogs and monkeys and mice and dolphins and other animals that can be presumed to be intelligent to some extent. And finally, when humans come through my door, I don't even think of exposing them to an intelligence test because I know that humans are intelligent, or at least I have to assume this. And a human would have to clearly fail in a very embarrassing way in front of me so that I can even entertain the thought that this human might not be intelligent, right? So if somebody comes through my door and I say, hello, how are you? What are you doing today? What questions do you have of me? And then he's just standing there looking at me without ever moving, without ever answering, then first I will get, nervous, perhaps call somebody security because this guy seems to be dangerous or deranged, or he wants to kill me or something. If he still doesn't react, then I might entertain the thought, perhaps something is wrong with this person. Perhaps he actually is not intelligent. His brain actually has undergone some damage. But I would not do this with any random person whom I meet on the street. I assume all these people on the street, all these thousands of people I can meet in a crowded city, I assume every one of them is reasonably intelligent and would pass a Turing test. So what do we learn from this? The thing is that normally we don't expose individuals to Turing tests, but we first have an assumption about classes. I say the class of inanimate things, except perhaps advanced computers, is not complex enough. The truly total Turing test, this is supposed to mean. So first, the species in question must pass a test as a group. That is, they must show that they are able not only to play chess, but to invent the game of chess. So now this makes it a little more difficult. An intelligence test for Schweitzer would not be to just be able to play chess. This is not yet intelligence, he says. Perhaps in this way we can distinguish between intelligence and creativity, right? So he seems to assume that intelligence is actually creativity, not only performing a series of algorithmic steps in order to successfully play chess, which most of us would already say is AI, but actually to invent the game of chess. This makes things even more complicated. It also makes them a lot more unclear. Is inventing a game fundamentally different from playing a game? Is creativity something fundamentally different from the execution of an algorithm? It is a very complex topic because originally, of course, you would say, yes, creativity, if you ask anybody, on the street, creativity seems to be something special. It seems to be some spark of godlike power that makes you make something new, and programs and machines and algorithms cannot create anything new. They can just replay what a human being has programmed into them. Now, if you think a little more about it, this doesn't seem to be true in this generality, because For example, I can make a computer program that creates art in the style of Van Gogh. We have such programs now, neural networks that create art in the style of Van Gogh, or geometric art. By using colored triangles and rectangles and circles, I can create a pleasing picture, and actually much of modern art is like that, right? There is a lot of modern art made by humans that consists of triangles and circles and colored rectangles. There's nothing more to it. So if a human can make this, then a computer can make this. And if for a human I categorize this kind of art under creative endeavor, then when a computer makes it, it must be also creative, right? I must be able to say it's a creative output. I can make it so that it doesn't repeat. The rectangles can be random. The points of the rectangle can be random points that a computer just takes out of its random number generator. So then every time it would be a new picture. You wouldn't have any reason to say that a kind of geometric artwork created by a computer is different in any detectable way from a geometric artwork created by a modern artist in itself. The only thing that might be different might be the biography of the artist. You might know this is a human and he thought about something while making this, and this is a metaphor for, I don't know, the Second World War, while the computer didn't think of anything and this is just random. But this is a kind of meta-knowledge about the artwork. It's not something that is in the artwork itself, right? So the question of whether inventing the game of chess is fundamentally different from playing it is an interesting, complex question that has to do with computer creativity. It is not something we need to answer now. Anyway, for this test, it seems that this is what Schweitzer has in mind. And second, after this has been achieved, after we know that this class of things is intelligent as a class, then we can test individuals by a token test, like the Turing test. Token means a particular individual is being tested instead of a whole class. So again, we saw that this also has its problems. It's not perfectly clear. It seems that every test, let's be bold in our claims, every test that I can think of for detecting intelligence in a binary way, yes, no, is probably doomed to fail, because intelligence doesn't seem to be a thing that you can switch on or off, or that you have or don't have. Because look, we have some degree of intelligence. Albert Einstein or Plato or Aristotle probably had a much higher degree of intelligence. My dog has some degree of intelligence, probably less than Socrates. A mouse has some degree of intelligence. A cockroach has some degree of intelligence. The thing is moving along, it's mating, it's finding its food. When a fire breaks out in my house, the cockroach flees the fire, it runs away from dangers. It seems to have some degree of intelligence. It is an adaptive, perhaps even a system that is able to learn. It's not clear. I don't think insects learn, actually. But, I mean, a bird can learn, right? We know that pigeons can learn to count beats or other things, or press buttons. So if I can train a pigeon, then this bird has the ability to learn. So to some extent, it is an intelligent bird. So it doesn't seem likely that we will ever be able to find a test that says intelligent, non-intelligent, because intelligence is a continuum. And even within humans, intelligence is a continuum. We are not all intelligent to the same extent. And also, we are not all intelligent in the same way. There might be different ways of being intelligent. Some people are better at manipulating physical things. They can do handicrafts, in some amazing way. Other people cannot do this at all, right? Some people have an artistic ability. They can be creative. They can translate images in their mind onto images into images on paper. They can draw stunning pictures. It's a kind of intelligent action, right? To translate an idea into a picture. Other people are able to write novels. They're able to write books. This is a kind of intelligence, right? If we say Rector is intelligent because it can create a story about Sarah and Bill, then Dan Brown must also be intelligent for being able to create a series of thrillers. But now you have an artist and you have a writer, and now is the writer more intelligent than the painter, or is the painter more intelligent than the artist? I don't think this question even makes sense, right? Probably we have to say that these are different kinds of intelligence. So the artist, the drawing painter, has one kind of intelligence. The writer has another kind of intelligence. The philosopher has another. The physicist has another. Obviously, theoretical physics is something that we admire as an example of intelligence. But what about all these people who have no idea of theoretical physics? Are they not intelligent? They are, right? And this is also a problem with normal IQ tests, right? IQ tests are generally considered to be insufficient to measure intelligence because, first, of course, they depend on culture and knowledge and so on. But even when they try to avoid this, they just measure particular aspects of intelligence and never the whole thing. And you might fail in one aspect and have a lot of intelligence in another aspect. Emotional intelligence, for example, is another thing, right? Emotional intelligence, some people say that this is a kind of intelligence, right? To be able to navigate human relations, to be able to talk to people, to open up to them, or to make them open up to you, and to make them do things, to motivate them, or to frustrate them, or to manipulate them. So these are all abilities that have to do with interacting with other people. Very often the people who are good at that are not good at very abstract forms of intelligence, simply because they prefer to be with people, and many abstract forms of intelligence are very isolated. They are very unsocial. If you are a logician, you spend most of your time, sitting on a desk and thinking about something, and you don't want anyone to interrupt you or to talk to you. So this is naturally opposed to the idea of being a very social person. So very social people often are not very abstractly thinking people, for the practical reason that their deep abstract thinking about logic is not social. And if you like to be social, you would not like to do that, even if you could. So you see that we have intelligence is something very, very complex, and probably every intelligence test is kind of doomed. And now how this transfers to machine intelligence is also complex, because then, of course, you have to recognize or realize that a self-driving car is a kind of intelligence, even though it doesn't pass the Turing test. And this is a problem for the Turing test. We have to recognize that there are kinds of intelligence, like driving a car, that don't express themselves in the ability to sort pictures, or to pass Turing tests, or to invent the game of chess. Okay, so we stop here for the moment. We will return to this topic later when we talk about Rodney Brooks and why elephants don't play chess. This is a famous paper that tries to make exactly this point about the variability of the expressions of intelligence. And we will return to this later. Okay, for the moment we stop here. Next up is the Chinese room. So return in a moment to get the last part of this lecture.